All right, this video is to demonstrate how to write the equation of a line. You should take notes on this video in your notebook so you can reference them later. If you lose your notes, this video will always be in Canvas for you to come back and look at later. So, since we're writing the equation of a line, let's just quickly review. The formula we're going to use, or the form we're going to use, is the slope-intercept form, which is y equals mx plus b. And in this form, remember that m is the slope, and the b is the y-intercept. So in other words, if I'm given a graph or information, the two things I really need to be able to write the equation of the line are the slope and the y-intercept. That's what I need. So the first type of problem we're going to look at is if you're given a graph. So like here in example number 1, we have a line. And so what we want to do is we want to, number 1, determine the y-intercept, which is where it crosses the y-axis. So that is the point 0.03. We're going to need that when we write our equation. And then I need to pick 2 points so that I can determine the slope. So again, it's useful to pick ones that are on the what we call lattice points. That is where the grid lines cross. And so there's 2 there. And so now I just need to figure out my rise versus my run. So I'm going to start down here at the bottom left. We've got 1, 2, 3, 4. And that's 4 there. So it looks like my rise is 4. I take that back. Let me make that green. So my rise is 4. There we go. And so now I need to calculate the run. Let's see. So I'm going to use orange for the run. So we're going to do 1, 2. So the run here is 2 units. Now, again, I always want to simplify. If you need to, take that, type it into the calculator, 4 divided by 2, ask it what the fraction is, and you should get a slope of 2. So now that I've identified my y-intercept, I've determined the slope of the line. Now I can go ahead and write the equation of the line. So I'm going to have y equals. Next is m, so here's our slope. We determined that was 2. Remember that the slope does not include x. X is separate from the slope. And then we have our y-intercept of plus 3. And that is the equation for that line. Going over to another example, let's take a look at example 2. Same process. I'm going to start by identifying my y-intercept. So here I have 0, 1. And now I need to pick 2 points to use for my slope. So I am going to go ahead and I am going to use, there's a point, that one there. And then I'm going to use this one down here. All right. So we're going to figure out our slope. We need to determine the rise over the run. So we're going to do our rise first. And remember, rise can be negative. It can be a misleading term. And it doesn't matter which point you pick. Just remember that moving down or moving left makes the number negative. So I'm going to move down. So this is going to end up being a negative value. So 1, 2, 3, 4, 5. So the rise, if you will, for this line is negative 5. And the run is going to be 1, 2, 3, 4. And so my run is going to be a positive 4. Now, again, put this into your calculator to make sure it's simplified, and you're going to get a slope of, it's just going to return negative 5/4 because it's already in simplest form. All right, so the calculator is going to return the slope of negative 5/4. Now that I've got the y-intercept and I've got the slope, I can go ahead and write the equation for this line. So I have y equals, now I'm going to write my slope, negative 5/4. Then we have the x, because remember the x is not part of the slope. And then I have my y-intercept of plus 1. And there's the equation for that line. So again, we need to identify the y-intercept on the graph, determine the slope of the line using rise over run, or change in y over change in x, and then write the equation. Now, in a coordinate plane or a graph, there are some special lines, all right, that don't necessarily fit this format of y equals mx plus b, because there won't be a y-intercept, or the slope will be 0, or something of that nature. So we're going to take a look at those just so you can add that to your notes. So the things we're going to take a look at is the equation for the x-axis, an equation for the y-axis, how we write equations for horizontal lines, and how we write equations for vertical lines. So the x-axis, that's this line in blue right here. So this one's going to be the x-axis. Remember, the x-axis runs left to right. Well, if we look at some of the points along the x-axis and write their ordered pairs, for instance, if I come over here and I pick this point here, the coordinates for it are -5, 0. All right, -5, 0 there. If I come here, the coordinates at this point are 2, 0. And if I go further along the line, like let's say over here, the coordinates at this point are 9, 0. Now, what you may or may not see here is that it doesn't matter what point I pick along the x-axis, the y-coordinate is going to be 0. The x is changing, but if I were to try and find the slope, I'll notice that I don't have a rise. So when I want to write the equation for the x-axis, it is always just simply y equals 0. And the reason that is the case is the y-intercept is going to be 0, because it's intersecting the y-axis right here at the origin. And because there is no rise, my rise would be 0, and I could pick any run I want, and 0 divided by any number apart from 0 itself will always be 0. So if I go back up to the top and look at my equation of a line that we're using, m would be 0 and b would be 0. Everything's gone, so just the equation here for the x-axis is just y equals 0. All right, y equals 0. Now the y-axis, which is the one that's vertical, here in red is my y-axis, so this is our y-axis here. We're going to do something similar. I'm going to pick several points along the y-axis. For instance, I could pick this point up here. This would be 0, 8. We could pick this one here. This is 0, 3. I could come down below the y-axis. I could pick this one here. And this will be 0, -6. So similar to the x-axis, what you should notice here, or maybe you haven't noticed it yet, all of the x-coordinates here are 0. So when we talked about the x-axis, notice all the y-coordinates were 0, and so we wrote y equals 0. Well, notice on the y-axis, all the x-coordinates are 0. So when I write an equation for the y-axis, it is always x equals 0. And so if you want to think about it, if you're dealing with one of the axes, you know the value is going to be 0, but if you're talking about the x-axis, it's going to be y equals 0. If you're talking about the y-axis, it's going to be x equals 0. So your equation is going to use just the other variable that's not used in the name of the axis. So last two things, horizontal line and vertical line. Let's say I have a horizontal line, all right? So here in purple, we have a horizontal line. So this here is a horizontal line because it's running from left to right. All right, so we have a horizontal line. And so on this horizontal line, again, what I'm going to do is a similar approach. I'm going to pick points on this horizontal line. So I'm going to come over here and I'm going to pick right here. This happens to be the point 9, 4. If I come, let's pick this one right here. This is the point 3, 4. If I move further to the left, over here, I have negative 6, 4. And so once again, you should be seeing that for this horizontal line, now this is not an axis, it's just a horizontal line, but notice how the y values are all the same. So when we write an equation for a horizontal line, we're always going to say that the y is equal to a number. In this case, it was 4, but it could be any number depending on where the horizontal line falls. So what we typically do is we say y is equal to a, and then we'll say a is a real number. So that means it could even be fractions, it could be irrational, it just has to be a real number. All right? But it's going to be y equals a number for a horizontal line. Lastly, we have a vertical line. And in this case, our vertical line. So we have our vertical line here, which is this green one. So this is going to be our vertical line. Whoops. Let me switch to green just to keep all the notes clear. There we go. So this is our vertical line. And we're going to use a similar approach to what we did for the y-axis and the other line. So vertical line here in green. Notice it is not the y-axis. It's a vertical line. It's parallel to it. And so on this vertical line, again, I'm just going to pick some points. So let's see here. This would be the point 0, 9. I'm sorry, not 0, 9. I take that back. It's not the y-axis. The x-coordinate here is going to be negative 2. So this would be negative 2, 9. So that's negative 2, 9. If I come down here, I have negative 2, negative 1. And if I go down even further, I'll have negative 2, negative 8. Now, similar to all of our axes and our other horizontal lines, you notice here in a vertical line that all the x-coordinates are the same. So when I go to write a line for it, we're going to have x equals, and in this case it was a negative 2, but it doesn't have to be a negative 2. It could be x equals 5. It could be x equals negative 17. So what we're going to do is we're going to say x is equal to b, and b is also a real number. All right, so you might be looking at these and saying, all right, well, if the x-axis is y equals 0 and a horizontal line is y equals a, is the x-axis a horizontal line? Absolutely. A just happens to be 0. And the same thing for the y-axis. You said, well, the y-axis has an equation of x equals 0. A vertical line has an equation of x equals b. Isn't the y-axis a vertical line? Yes, it is. B would be 0. But it's more appropriate to call those the x and the y-axis versus just any horizontal or vertical line. So that is the end of this video. If you need to go back and look at any of the notes or write anything down, go back and pause it or listen to it again. And if you have any questions, let us know in class.